Okay, I'm here. Windows decided to, or OBS decided to change my audio device. It does that now and then. Okay, literally nothing has been done. My microphone's still stuck in all kinds of stuff, or my headset. I don't need this. The lights aren't even on. I was running so late because my dinner arrived like half an hour later or something than I was expecting, and well, that turned into this mess. My desk is a giant mess from everything I've been doing this week, so let me try and order that somewhat. Okay, let me turn down the music. There. I haven't even turned the lights on yet. Okay, let's see. Home Assistant. Okay, we need this one doing this effect, and then we need this one doing that effect, and I would like this one to do this effect. Okay, good. And I want these and these. Yes. Okay, and I need to fix the top cam. This is wrong. Oh, okay, that's right. But we're not in the right mode. Okay. That's good. What value? Oh, that's way too high. Okay, so now we also have a top cam, I think. And it looks a bit overexposed. But once the outside lights go down, it should be okay. What do we have here? It's a prototype. There's so much crap on my desk. It's unbelievable. Okay, don't need that. Don't want that. This goes here. This needs to go here. Okay. I think we're mostly there. Who did put it there? I wonder who did. This week was kind of crazy in regards to announcements and things like that with the 24-volt issue. Have you all seen the 24-volt issue announcement? It's one of my less greater days. Martin Mueller didn't put it there. Okay, we're somewhat in working order. Or are we still in the pre-stream? It's all mixed today. I also didn't prepare the stream at all. So, I don't know. We'll see what happens. Okay, where's my phone? The outside light goes... Yeah, the sun sets. Yes, that's what that means. Yes. Okay. This is the secret time. No, the secret today is that we have an issue with 24 volts. You saw the Reddit discussion. Okay, yeah. Yeah, that was one of my less great days. Oh, the Dignex 4 is way off. The first prototypes actually did a lot of things right, but I've decided to change a lot of things anyway, to make them even more betterer. Oh, we don't have background LEDs. So, I don't know. 6 months? Let's try 6 months. That sounds like a nice number. Okay, let's do something in the background. Let's do puddles. That is insane. Let's not do puddles. Why is it like that? Okay, let's do rain. That's nice. Rain in orange? Rain in orange it is. All good. Good. You know, soldiers, that's what we're trying to do. We've been investigating this issue for a while now, especially Paolo and Philip and everyone on the Discord. We've been keeping an eye on it. And now that more is clear, you know, we made the articles and we came out with, you know, that there is an official problem. So far, I've had about 6 boards outside of warranty that have been submitted, and about 6 to 8, I think, within warranty. And out of the thousands of boards out there, that's not a lot. Now, we've seen the issue maybe 10 or 12 times before the announcement, so I don't know. We just have no clue how many there really are, and how many it affects and how many will last or not. That's why I try to do my best on the mitigation article, so you can prevent the problem, or if you've had the problem, the remedy, or the revival, as I call it, where you can basically still use a board that died with just a few external components. And I'm putting together kits, which I will be selling at cost or providing for free, depending on the situation, for warranty or non-warranty, etc., which will basically allow any board to work again, even if it's broken. Doesn't matter if it's a Dig Uno, Dig Quad, or Dig Octa. So even if the chip died, we can revive the board with some external components to basically function like it did, just with a few extra wires. So, have I tested what myself to see how it handles 24-volt soul juice? Yeah, true, Greg. I mean, it still sucks, but I'm trying to deal with it in the best way I can think of, and yeah. So let's see who's all here. Dutch Maker was the first. I'm not sure he's still here, but we'll see. And Nigel Young, Greg E, Draadstaal, and Music No Sound Quindor. Yes, Windows and OBS. Yeah, I think when my microphone unplugs, it's a USB microphone, it switches back to default microphone, which, I don't know, then isn't this microphone. It's a mess. It's a quick fix, though. Still in the pre-stream. Yeah, we'll call this the pre-stream. Oh, about the, yeah, I believe so too, Philip. And we've all been running them at 24 volt. I have been running a few boards at 24 volt and haven't seen the issue myself. I have no boards in-house with this issue. I got some back when the issue was developing, but I haven't had a failed board myself. So I've had to simulate failures. But, yeah, sure, Greg. Oh, let me give you a link to the article. That's a good one. No. That is this article. And as I said, there is mitigation. So if your board is still running and you want to prevent the problem, revival if your board died and you want to, revive it, or fix and repair where you have to solder. And as I said, I'm making mitigation and revival kits where everything is included, and I'm hoping to be able to deliver those for like $5 or something like that. I don't know. Where I can provide them in warranty if your board is still in warranty, and outside of warranty you might have to buy it, but yeah. But that would prevent throwing away broken boards, and the problem is shipping, and shipping a board back is almost more expensive than the buck converter kit would be. Now I have to ship it too, but that, I don't know. Just a lot of shipping back and forth. Shipping is so expensive nowadays. The buck converter kit is a very nice solution because it can make the boards that broke run again, because all the other components on the board are fine. So, about the network issues we had last week, I did some tracing on that, and I think one of my switches overheated during one of the hottest days we had, and it basically never recovered. Now, I shut it down, and I took out the SFP Plus modules. There's two 10 gigabit SFP Plus modules in there, very close together. That might be an issue. But I think it overheated, and I got into a weird state. and after I unplugged it, let it cool down, and plugged it back in again, I haven't seen any ping drops yet. And let's see if we also don't get any frame drops or dropped frames on the network as we saw last time. So hopefully that solved the issue. Yeah, Marcus, it all depends on the outfall. How do I say that correctly in English? The how many boards are actually dying, basically, right? And if it's only a few, I'll even reach. I have a form where even people without warranty can still register, and I'll deny the warranty. But if I can do it and there's not too many boards, I'll even go back, and then I have an archive and an email list, etc., where I can contact those people and still send them a free kit. But that's only if I can, right? It all depends on the next few weeks. Fallout. That's what I was looking for. Thanks, Philip. So in the end, Greg, the fancy relay mod will be included in our firmwares. We just haven't gotten to that point yet. We could do a renewed user mod video, sure, at some point. Nowadays, AI can help you out. There's a new AI model today, Fable 5, which we used and then was permanently, or not permanently, immediately banned after the stream. There's now Opus 5, which is supposedly almost better than Fable 5, so I don't know. If we need AI today, we'll use that. Jet has stepped on your dig quad no less than 50 times. What Jet is? What kind of person or animal is Jet? I try to, Greg. I try to. I mean, if I just promise everything and then go bankrupt, then no one gets anything, and there's no products anymore. So I'm trying to manage it correctly. He's your toddler. Oh, okay. Claude is good for user mods. Yes. No, Claude is generally just good in coding, and coding advice and telling you how to do it. Or actually, if you do it in Claude Code, which is in the desktop app, it'll if you just tell it like, okay, build me a firmware file for WLED with the configuration for a Dignex 2, and then maybe point it to the pinout article, and integrate this user mod, it'll probably just compile that firmware for you. You don't have to mess with Visual Studio Code, anything like that. And after the stream, it will get pulled again. Yeah. Yeah, so my Power Manager user mod is like 99.98% Claude code. Because I can't code for crap. But I have, I spent a few days with it, working through iterations, changing behavior, and, stuff like that. Are you going to share credits with your firmware builder? You're on there, Philip. I believe you're a contributor in the GitHub and stuff like that, aren't you? Philip does all our firmware compiling and uploading and managing the install website, stuff like that. Right, while we're waiting, let's see where we are. Let's disable something real quick. Bookmarks. Okay, this needs to go here. Oh, I hear the new ChatGPT Soul is quite good. It's comparable to Fable, so that's good. Let's see. Okay, good. Does this still work? Yes, it does. Oh, it's just smaller now. Okay. So let's see if there's a new version of 10. Yes, I think there is. 22nd of July. Yes. Okay. So the first thing we always do in these streams is update the software, because that's what you're supposed to do during streaming, right? No AI for me, all manual labor. You know, that's all good, also good. I used to do that too, but now AI does the stuff I don't know how to do. So let's see here. Last time we saw a slow upload, didn't we? I think so. Let's first test something else. Let's do a quick speed test to see if now the upload is also fine again. So downloads around 900, that's what it should be. Nice, Martin. I think it could be a great help during coding, but you know, that's up to you. My upload's still crap. Not sure why. I'm not getting any frame drops though, so that's good. Okay, the upload's still crap. Well, you mean 400 megabits is not crap, but I mean, yeah, I've only, you know, I tried to use it in my work, and for that it's been really good. Wait, I need this. KiCad. So let's update KiCad and then see where we left off. I believe we were trying to decide if we wanted a port expander on the base PCB or not. Let me move this there. And we were counting I/O lines and stuff like that. So today I think we should work on thinking out the baseboard more, and then see what kind of connection we want to make to the sensor board, as I'll call it. And we need to count like I/O lines and power lines and ground and stuff like that we need there to determine what kind of width cable we need. And I think we're going to go with like 12 or 16 pins or something like that. So we can do some I2C, and we can do some, I don't know. Oh, wait, where, I'm on display capture. How did, oh, sorry. I enabled the wrong one. I'm basically using this display as a capture because KiCad has so many different windows, which are all different applications. It doesn't really work with program capture. Okay, so our KiCad is back. Good. And let's go back to our schematic. It's very slow. Okay, maybe that's just 10. Right, and last time I dragged in our I2C. It turns out the board I use this on indeed has it reversed. So this needs to go... Oh, wait, what? What's going... What do you... What? What makes... What? Come on! Okay. Okay, let's move everything over one tick or something. There. Okay, great. No, I did it wrong again. Damn it. There, now it's fixed. Okay. Anyway, this circuit works. I tried this on the DigNext 4, which has the same I/O expander, and also now the programming, thanks to Claude. It wrote a driver for this I/O expander, and that's been working great, as we saw in the last stream. That Foxionaire, that is also my opinion. Like the new AN Penta website, and I don't know if you've actually seen these. So, for instance, I've made dignext.info, which is a new website for the DigNext, and we already have some stuff there. And this is all made together with AI, because I can build websites. You've seen QuinLED.info. It's not great. It's fine for technical stuff, but it's not very pretty. But this is, made with help of Claude. And it's just the same information, because I told it to use all information from QuinLED.info, just laid out differently. And it has like a setup guide with nice and flowing diagrams and things like that. And then it also has like some tips and tricks, like the FAQ. What is a QuinLED dig next to? And how do I need to know how to code? And, how many LEDs can it drive? It's all the same information that's basically already available, but then presented in a nicer way. And this one came out especially nice. an-penta.info for the analog controllers, and it made like a simulation for like cheap PWM controllers and how an an-penta does on camera. It even generated these AI images. And, you can select some of the boards. It made some nice overview tables. It has like a broken fuse simulator. I don't remember how it works. Wasn't I able to... Oh, yeah. Simulate a short. So, yeah. Oh, I hope she's okay, Philip. And it also made like this CCT slider. Because for analog, that's nice. And it generated all these nice example images. I used my RTX 5090 to not burn up any cloud. So that generated all these images. And it created a website I could never do myself. So, yes. Very, very happy with that. Oh, and there's also dig octa.info. So that has all the dig octa boards on there. So you have the brain boards and future brain boards that are coming, the power boards, and this one also has like a broken fuse simulator, and it also has a power calculator type deal. And I've been messing with that. It's pretty funny. So like it takes the data from my own table, and then you say like, okay, I have 600 5-volt WS2812B. It says, okay, the theoretical maximum for full RGB white is 36 amps. But you can say, okay, you want to calculate with 35 or 50%. And it'll tell you like, okay, for 35%, you need front plus 1 middle plus end injection. And this needs 2. And it fits on a power 5, but if we increase it, like, okay, if above 50, then you need a power 7 HC, and, it didn't think of this itself, but I guided it through what I wanted, and then it built it for me. So, that's really nice. And, of course, we've all seen that. QuinLED.shop. So we can go to digital, and someone mentioned something about a table. Well, here we go. They are all static, except this one. It uses some kind of framework, but I forgot the name. But yeah, this also works very nice. I had my RTX 5090 generate these flags because I thought they looked cool. It's an AI double, yes. Yes, I need to... I was trying to talk out of order. Talk out of order, I should. No, I'll just sound like Yoda. Talk out of order, I should. Yes. No, okay. Yeah, but this worked out really nice. And it gave us a much better shop aggregator than we had before, basically. Cloudor! Yes, it's me, Cloudor! Oh, I also added warnings about the 24-volt issue to all relevant boards. So if you go to a QuinLED Dig Uno, you'll see this known issue notice. And if you then go down, it'll give you the form or come to the Discord or the article. And yeah, there's warnings on all the places I could think of. Yeah. AI Quindor is the reason 24. Yes, we'll keep that. Yes. That is exactly what happened, Philip. It's not my fault. It's Claude. Or as I call him in Dutch, Claude. And if you're Dutch, you understand what that means. Because Claude clothes a lot together for me. Like he clothed this website and, he did pretty good. Okay, let's go back to here. In elkaar gekloot. Ja, nee, zeker. Anyway, so this port expander with the code from Claude works great. So we can use that also in our sensor project. We already did the whole PoE circuit and then the 12 to 5 volt and the 5 to 3.3 volt and things like that. We have the connector. And we were trying to figure out how many pins we need. I don't remember how many pins we have. I guess we should count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13? There is an I2C here, but that's already being used on the baseboard or on the display itself. Yeah, so we have 13 free pins. Oh wait, these are TX and RX. So we have 11 free pins. Let me make a note. Wait. No. Everywhere else in Windows or on websites or whatever, Shift-Enter is a new line without acknowledging the dialogue or the post or whatever. But enter here. Enter is a new line, okay. But Shift-Enter is okay. Why? Why change all the conventions on the internet to do it your own way? Excluding onboard I2C. Okay. So we have 11 pins. So for button inputs, relay, I2C, okay. Yeah, okay, we don't need I2C1 because that's already present. Random sense pin. Okay, so 4, 6, 8, 12. Okay, so we already need 12 pins to support like 4 buttons and 2 relay outputs and some random sensors and things like that. And then we still want LEDs. Okay, I've been thinking about that if we could make it WS2812 or SK6812 or something like that, instead of using 4 times RGBW. We didn't need any effects, did we? Yeah, I guess we can just blink colors. Because then we only need 4 channels. That's right, because then we only need 4 channels from here. Okay. So let's map these, right? So let's say the button inputs. Okay, well, we're going to make 2 tables. I'm going to call this, direct and expander. So our button inputs, our 2 relay outputs can be from the expander. But then our extra I2C pins and our random sensor pins need to be direct. And our 4 times RGBW channels Yeah, it can actually just be a single pin from the microcontroller if we use addressable, huh? And then we could do some cool effects. Would we need 5 volt for that? I don't think so. I think we can run them on 3.3 volt. Keep it in sight how many fingers Quindor has. It might be AI. Exactly. Who knows? Let's go to LCSC. Wait, why are you here? And let's look up SK6812. And let's see if we can... oh, Jesus, stupid. SK6812, there. So I want in stock, apply. What is the cheapest one? They're 2 cents. Oh, these are not... I'd like RGBW. Can I specify RGBW? No. Okay, well, we'll just have to look. Nope. 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 I want the cheapest RGBW. Nope. What's this? Oh, 2x2. That's nice. Yeah, I'm trying to find out. Okay, here's the cheapest one. This one has a RGBW, so it has the dedicated white. Oh wait, it has 6 pins. Okay, it's 6 cents. So I want to include at least 4. So that's 24 cents. That's okay. And it's 3.7 by 3.5. Okay, so it's smaller than 50/50. Yeah, it's mini. Okay. Okay, it lists it for 5 volt. I was wondering if we could run them at 3.3 volts. Yeah, so it has a dedicated white. That's good. Oh, you can get them in all kinds of color temperatures. This one's nice. Can we get this? That's a really long model number. Oh yeah, they have them. Is that? No. No, we need a GWP6. No, they don't have it. Oh, okay. Well, maybe we could order it. I don't know. Anyway, can we run this on... So it has VDD... 2 VDDs? Okay. Non-connected? Why do we have so many pins? Okay, well, I'm not going to worry about it. Sure. Yeah, okay. Damn it. Okay, working voltage, 3.7 to 5.5. Okay, so this will not work at 3.3 volts. So that would mean the remote board needs 5 volt also. Okay, so let's remote board pins needed. There. We need 3.3 volt. Oh, damn it. So for power... Oh. Okay. It's really annoying. I want 2 times 3.3 volt, 2 times ground, 1 times 5 volt. Okay. Because I want a really stable 3.3 volt, and the connection I'm thinking of using isn't very thick, so... Okay, so for... let me align that. Is 5 pins. Yeah, no, it's just it's the reverse behavior of what I'm used to using. So I'm constantly doing it wrong. Okay. Let's say logic. We need one time. We'll call it this, but then we'll connect SK whatever. 2 times for I2C. What else do we? We're probably going to have 2 times random sensor. Okay. And okay, well, that's it for now. Oh. So that is 5 pins. Right, so we're up to 10 pins that we want from this baseboard going to our sensor board, which will sit besides it. The LEDs we're going to change. And 1 times... I said 4 times random sensor pin. I think that's a bit exaggerated. Well, maybe not. Maybe not. Let's change that. 4 times random sensor pin is 7 pins. Okay. This we moved. Okay. Okay, so we've determined we want an I2C bus going to the sensor board, which will be a different one than the internal I2C bus, because there's already stuff connected to that and I don't want to extend that too long, so we can just use some extra pins for that. We got random sensor pins, can't use an IO expander for that, and we got WS2811 LEDs, only need a single pin for that. And then we're going to run stuff off of the expander. Now the expander will connect to the onboard I2C, I think, because that's still fairly close and it's not hopping 2 boards basically. And that will give us our button inputs and our relay outputs, but that will remain on the base board we've been developing. That won't be on the sensor board basically, right? So then remote will need 3.3 volt, ground, and 5 volt. Okay, this doesn't make sense like this. There. And then logic-wise, we'll need our LEDs. We'll need some I2C, and then the random sensor pins. So that is 7 plus 5 is, what is that, 12? I'm not allowed to calculate on stream. 5 plus 7, 12, yes. Okay, so we need at least a ribbon cable that is 12 pins. Now let's see if we can find that kind of stuff, because we just checked. We can find some random LED we can put on there. There might be smaller ones. We can check that real quick, because we sorted by price. Oh, okay, it's already done. Yeah, but you know, having an RGBW LED or 4 on there, that could be nice. FPC. I want to use an FPC connector. And let's see what... Go away. This is not the FPC I'm looking for. Oh, the drinks are right here. Sorry, I was so hurried. Yeah. What did they call them over here? Fiber optics. Yes, we're going to link the 2 boards together with fiber optics. No. I thought they were FPC, but maybe I'm misremembering. Yeah, I'm just going to go by the data sheet, and there it says the working voltage is 3.7 to 5.5. Yeah. 10 gig E. Yes, yes, Martin. We'll at least have enough bandwidth and heat. Let's see. I thought. Why is it not showing up? I might need to open. Oh, flat jump. Is this what I'm looking for? Yes, this is what I'm looking for. I want to use one of these cables to go between the baseboard we're developing and the sensor board we'll develop after that, to carry all the connections over. It's a easy, flexible connection, and they can easily be like 10 or whatever centimeters long. And then we can make a, easy to route connection between the boards. We just said we needed 12 pins. But let's, we might need more. So let's say we need 16. Do we have, okay, we've got 16 in stock. So these are all 0.3 millimeter, okay, 0.5 millimeter pitch or 1 millimeter pitch. They're 10 centimeters long. As long as we place them on the edge, they're basically right next to each other. So that should work out. And these are 4 cents a piece. Okay. It seems the 0.5 millimeter are better in stock than the 1 millimeters. Let's also look at 12 just to make sure. Yeah, 0.5 is much more represented than 1. Okay. Let's see what is most in stock. A 22 pin, really? Okay, and what's cheapest? Oh, wow. Okay. Cheapest is 5 pin, 10 pin, 9 pin. Yeah, but I don't care about a few cents. Yeah, but 0.5 is definitely cheapest. No, we're talking like milliamps, and we'll have to look in the data sheet. Okay, let's select. I feel more comfortable selecting a 16 pin if we need 12 pins. The other pins will just make ground, right? Or maybe an extra 3.3 volt or 5 volt pin or whatever. We'll always need more pins. But let's see between 16 and 20, what is the cheapest? Yeah, that's what I thought. A 20 pin is the same price or cheaper than a 16 pin. Okay, they have various in stock. That's all fine. Okay, let's take a look at this 20 pin over here. It's from Shenzhen Yuxua. Okay, great. Let's see here. Okay, so it's a ribbon. It's one of those flexible cables. Do they have a current rating? 60 volts. That's fine. What's this? Translate. Width. Okay. Oh, okay. Yeah. Let's see if they have some kind of rating here. Thickness. I don't think they have a current rating on this one. Let's try the other one. Oh, it's from the same brand. Probably it also don't have a current rating. We could ask AI. Let's see if we can find a different brand. No, there's no different brands. Okay, let's clear this. And we're going with 0.5 millimeters. Everything is from the same brand. Okay. Damn it. Okay. Do I have Claude on here? We're going to ask Claude. Let me open Claude. Claude. And we're going to use the new model, the Opus 5 in extra mode, for a 0.5 millimeter 20p FPC cable of 10 centimeters long. What is the current carrying capacity per pin? I can't write. There. Let's see what AI tells us. While I get a drink. See, that's how AI works. You ask it stuff and then you get a drink. No, I bought a flat fee subscription, Philip. So I have to ask it more. Oh, maybe it's not the... Okay, so let's say we want the 20 pin, right? Okay. Oh, they have a same side and a reverse. Sure. Oh, good. We also need a connector. FFC. Should I search for FFC? Contacts? Is this the... Ooh, okay. Yeah, we want these kind. Okay, we just selected 20 pin, but I also want to know how much a 16 pin is. There's no 16 pin connector. What? Really? Oh, not 2 times. 16p. No. Okay. 20p. There is, but 2 times. I am confused. Yeah, this is the type of connector I want. See what AI is. Okay. For a 0.5 millimeter pitch FFC FPC, the practical answer is 0.5 amps per pin, or roughly, if all 20 pins are carrying current, well, they won't be, they're carrying signals. AWD 37, okay. 0.3 millimeter wide conductors on a 0.2 millimeter spacing. Okay, yeah, sure. Right, and then we get voltage drop. That's good. So if you're doing half an amp for a single pin, you get 82 millivolts drop only, and then we have some contacts drop on the 2 connectors, and the drop per conductor. Okay. But we're going to use like 100 milliamp, maybe 200 at most. Okay. Yeah, so watch out for voltage drop. Okay, so if we do 2 pins for 3.3 volt and 2 pins for 5 volt, and then like 2 to 4 pins for ground, we're like way ahead in regards to voltage drop and things like that. So that's fine. But can we find a connector? That's the question. Because I want this type of connector. But this is... They don't have 20 position? Maybe I'm looking at this wrong. Number of contacts. Oh, here we go. 20. And I also wanted to see 16. Okay. There we go. Cheapest one. Okay, that's... No, wait, that's most expensive. Yeah, that's fine. And we have to look at what kind of latch mechanism they have. Because I do want... No, I won't want it like these. You can whip up or move up the black bar, insert the cable, push it down again, and then it makes a pretty good connection. This is for a 16... Let's see if we can find something similar. Yeah, this is for a 20. Okay. Let's see if they mention the amps or the pins stuff in here. No. 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 Nope. Okay. Oh, wait. Okay. Recommended max voltage 30 volt. Recommended current, and that's then per pin, 0.4 amps. Okay. Well, as I said, we're going to use like 2 for, especially if you use a 20 pin, we can use 2 pins for 3.3 volt, 2 pins for 5 volt for the LEDs, or maybe something else. And then maybe like 2 or 3 or 4 for ground. You know, if we have 20 pins, that should be plenty. Philip is the CEO. Doesn't he have control? No, he's like a paper CEO. Claude said to use, we could use up to half an amp. But we would have to accept, a pretty good voltage drop. So it kind of recommended doing a bit less. But in the end, I think we figured it out. This one, yeah. Does this have? Let's import these. Does this have a symbol? Yes, good. So let's make sure we get these. Let's save this in PCB editor. Let's import that part. Stupid notice. Did it anyway. And then we need the other part. The cable. Well, I guess there's not much to import on the cable. Wait. No, there's no PCB symbol to import for the cable. Okay. Okay, so we imported that thing. Let's see if we can add it. How did we call that again? Q import? That's what I normally do. Yeah. Okay, and here we have it. Here is the connector. We imported it from LCSC. And now we can start putting our, our assigned pins on there for what we just determined, right? Sorry, I'm not really following chat. What? Okay. Anyway. Do we already have 5? Well, we have 12 volts. And we have 5 volt. Okay, let's get some 5 volt in here. And let's rotate that. There. Let's get 2 5 volts. And we also have a 3.3 volt. So let's get 2 3.3 volts. And let's get some grounds. And for ground, I'm actually going to be staggering them over the connector. No. Oh, they have a shield pin. Okay. Shield's going to ground. So we'll have 2 going to ground here. And we'll have 2 going to ground here. And we might end up adding a ground somewhere for like, we have the I2C signals, and we might want to isolate those somewhat, so have like a ground between the I2C signals and the LED signal or something like that, right? Oh, that's true, Chris. If we could, yeah, but yeah, I don't want to interleave them, but I could spread them more. So we could say, okay, that's a good point. We could say, okay, 3.3 volts going to go here. And then we have our grounds. So now we have 5 volt at the top here. Okay, these need to move. That's a good point, Chris. Thank you. Right, so we have 5 volt in ground, and we have 3.3 volt in ground, and we'll probably add some more grounds, because we have spare pins, basically. And, yeah, we should have more than enough pins to carry whatever might be needed. Okay. So this is already done. Okay, I'm going to change this to what we actually did. Eight pins. Now we need some WS28 blah 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 logic. I need to see how we want to put this in the schematic, because we're also kind of using this as documentation. I believe there is no assigned pins, because this is an ESP32P4. So we can basically use all the pins. I'm going to try and not use any of these. So we'll start with these. Now these already carry I2C, so I don't want to have 2 I2C lines close together. So we're going to use 21 and 22. But now it doesn't really make sense what these are. So I'm going to label them. And this will be I2C 2 SDA. And this will be SCL. So now these are connected together, so we kind of know what is what, right? And now we can use these labels to connect them to the pins. And as I said before, I'm going to add a ground here just as some basic form of shielding, I guess. I don't know. You can't have too many grounds. Okay, so we're sending the second I2C that's linked to these pins to the remote board. Let's pick, I don't know, GPO5, and let's call that LED data. And then, oh wait, where there? We'll send LED data. LED data has very sharp edges, so I'm going to add another ground. And then we already have these, okay? And we want some random sensor pins. We don't know what sensors we're going to have yet. We're just going to add random pins. So we can use this one, this one. Okay, I'm going to change this. And we're going to have these. Oh. Okay, whatever. And we're going to call these sensor 1. Sensor pin 1. There. We don't know what they're going to be yet, so we're just going to prepare for it. Okay, so we have 4 sensor pins. That needs to go on here. And then we've kind of already run out of stuff that we need to do. So I'm just going to move it around. I don't know. We're going to add lots of ground connections. There. And if we decide we need more than what's currently on the connector to the sensor board, we can just remove one of the ground connections and use that lane for it, right? We're not stuck to anything yet. I just want to have some kind of, you know, resemblance of what we need to go to remote board. Now we also know what pins are already used. We still have 38, 20, 32, and 46 left over. So these are still available for other stuff. Yeah, we did all that. The expander is going to do all the buttons and the relay button inputs and relay outputs on the baseboard. I guess we could make some terminals for that. Where's my expander? Here's my expander. It's going to use the ESP I2C because I'm going to have 2 I2C buses. That's no problem in ESP Home. So the first one will be on the P4 board, the display itself, and then this board below it. That's pretty close still. And then we'll have a separate I2C bus for the remote sensor board. I think that's better for signal integrity and stuff like that. Okay. Well, we could make some labels. I don't know. We'll call this button 1. Button 2. Button 3. Button 4. And we'll also call this relay 1 and relay 2. And since those are on the expander, this would have cost us 6 pins. But we only have 4 pins left. But because they're on the expander, they now cost us 0 pins. Because we're using the I2C that's already available. Right? So we did this solid state relay. Right, we have a terminal. Oh, we connected this to a GPIO. Well, we're not going to do that anymore. Plus 5 volt or minus 5 volt. Does it need 5 volt? Because then we need to build a circuit for that. Let's look up the relay we once selected. Probably does need 5 volt. TTL. Oh, okay, maybe. Let's see. What does this mean? Input voltage range 4 to 6. Okay. And then ensure the voltage is on. So that's probably the switching current. And this is the switching resistance, input impedance. Okay. Right, and we selected the KS524Z2M, 5 volt, 240 AC VAC, that's fine. 2 amp? Oh, okay, it's not a lot, but okay. Hey there, LED scientist! Okay, so we need 5 volt to switch this, but our I/O expander, oh, that's wrong, is running on 3.3 volt. So Oh, I actually might want a different LDO for the sensor board so that it gets a clean 3.3 volt. Yes, I do. Okay, we're going to clone this. We're going to move this. And then we're going to clone it. Because we're going to have 3.3 volt on this baseboard. And I want a separate LDO for 3.3 volt on the sensor board. So that it's a nice and clean 3.3 volt. So we're going to give this a different signal. 3.3, and we'll call it... Oh, they don't have a 3... Oh, okay, we'll call it A. Yeah, we're designing a custom PCB for a existing product to do PoE and all kinds of sensors and stuff. So we're kind of expanding on an existing product. So we'll call it 3.3 VA, and that's going to go to our remote board. It's kind of overkill, but sensors need a really stable power supply, or their measurements can be slightly off, and you won't notice, but it'll still be, what's going on here? Why do you have 3.3 on the multi-cable then? What do you mean? Oh, no, I do want to generate the 3.3 volt here, but I don't want it to be contaminated by other stuff on the same reel. And I believe these were like, let's see how much they were. I don't think they were very expensive. Oh, 15 cents. Yeah, I'd rather have a second one, even though it's an extra 20 cents because of the capacitors and stuff. And have a really clean 3.3 volt than not. So it might be a bit overkill, but you know. Okay. So we were dealing with the issue that, oh, I didn't rename this one, that these relay outputs are 3.3 volt because the expander is running at 3.3 volt. Why not put 5 volt on the multi-cable and then the second LDO and sensor? The reason for that is the LDO will generate heat. Even if it's even just a slight amount of heat, it'll generate heat. And part of the reason why I want to have this baseboard and then the sensor board basically next to it is because I want to separate the heat. The PoE circuit will be making heat. The LDOs and the switching circuit will be making heat and noise and all kinds of crap. And we're going to separate that with the flex cable to basically the socket next to it. And then there's no heat generation on that board. So things like temperature sensors and other stuff will be more accurate because there's no heat generation on that board itself. That's the idea. It's again not the cheapest approach, but I'd rather go for good. Let's see. Do I have an M? No, I don't. Okay, we're going to use a load switch, as that's called. And we'll use this one. So these are load switches with an enable pin. They're dirt cheap, 4 cents. And you can run them with a 5 volt supply. So V in. And then the enable pin can be 3.3 volt, or it should be. So we can run them for 5 volt, that's fine. And the enable voltage is minus 0.3. Okay, yeah, okay. So it can be below, it can be minus, or let's say 0 to a little bit above V in. But do we have a switching characteristics? Turn on volt. Okay, logic low voltage with V in between 2.5 and 5 is 0.8. But more important, the logic high voltage, even if we have 5.5 on the input, we'll have 5 volt, is 2 volt. So that means we can power this IC with 5 volt, and we can use a 3.3 volt signal to switch it. Okay, does that make sense? So we're going to steal this one. Yep, it has a footprint and everything. Good. This one. Import. And using such a load switch is better than you often in online examples, you'll see them using level shifters and I don't know, all kinds of crap that isn't meant for it. I don't recommend that. Just use the proper stuff. These are like 4 cents. Come on. Okay, we need some components for that. We need 5 volts. Oh, this is one of those Chinese symbols. Let's see. Transform horizontal. There. We are Europeans. We go left to right. Okay, so we have 5 volts. We have our enable pin. And I'm going to do overkill because do we have a small resistor somewhere? Let me see what kind of resistors we're already using. We're already using 10K. But it's an 0805. I don't want an 0805. Oh, we're also using... Okay. So I can steal this one. Because we're going to pull our enabled to ground with a 10K resistor. So that we basically always know the state it's in. Now, with the I/O expander, that's not really needed because of the way this one works. But we're going to do it anyway. No, let's do this. So we have relay 1 coming in here. And that will be either a 3.3 or 0 volt signal. But if the signal is undefined, you kind of want to give it a state. So we're saying, oh, what's going on? We're saying, okay, I'm using a 10K resistor to pull it to ground. So by default, it's 0 volt or ground. And then the 3.3 volt can easily overrule that 10K resistor. So we have a clean on and off, basically. Now we need some capacitors, because these need capacitors on the inputs and the outputs. Let's see, 22 is a bit much. Cramming in a whole week of work in one day. Nice. Okay. We'll reuse this one. That's enough capacitance. That's fine. Kind of screwed myself here. Oh, I can... Yeah, okay. There. We'll do it like that. It needs an input and an output capacitor. Yeah, I use these ICs more often, but I kind of glanced over that. Sorry. Let's take a look at the datasheet. If we look at this datasheet, so it has a slowed on-off to meet USB specifications. That's only good. It has very low, or fairly low resistance. That's fine for what we're going to use it for. It has reverse current blow blocking. Don't really need that in this application. Although if the relay would kick back something over its I/O pin, it would at least not destroy the circuit, unless it destroys this IC, maybe, but... it's meant for hot plugging because it has a slow ramp up. which is good. And if you look here in the datasheet, they recommend a 10 microfarad on the input and the output. Now, I'm not sure it needs to be 10. Let's check that. So they've measured the on-off. Oh, here it's a 1 UF. What? CL? Is this CL? C in, C out. We don't have a CL. Okay. There's no ESR requirement. We're using ceramics, so that's fine. C-in will dramatically reduce the voltage transient seen by the power supply and by other circuits upstream of the MT. Okay, so if you're switching a larger load, the capacitors will help not drop the line too much for the regulator and stuff like that. Output. No, we're not going to use electrolytics. We don't want that either. Well, basically, they recommend a 10 microfarad, but we're going to be switching like, I don't know, 50 milliamps maybe, instead of like an amp. So we're not going to need anywhere near that. No, for certain applications, you can certainly have too much capacitance, like a switcher like this. Yeah, so you shouldn't go overboard. Or an LDO or a buck converter or something like that. You can have too much. But it does depend on what kind of capacitor it is. One of the things we need to do, I'm going to stick with the 4.7. As I said, the load we're switching is very low. We're basically using it almost as a level shifter. And then the 4.7 will be fine. If we were switching like 1 to 1.5 amps, maybe that exact capacitor size would be more important. But for this application, actually, we can check. We need to check in the data sheet because it doesn't have a power pin. Okay, let's check that somewhere. Here. How many milliamps do you draw? Leakage. Okay. Maximum input current, 25 milliamps. Okay. So when this solid state relay switches, it can use up to 25 milliamps. That's a lot for a level shifter. So I wouldn't recommend a level shifter, like a lot of examples online, which are wrong. But 25 milliamps for this load switch is peanuts. So I think we'll be fine with our 4.7s, and I'd rather reuse a component we already have on the board than introduce a new value if we don't have to. Oh, you were thinking in terms of car audio. Yeah, but that's because for car audio, your source is a battery which can deliver hundreds of amps, and that's no problem. But if your source is limited, like an LDO or a switcher or something like that, and you have a giant low resistance capacitor bank behind that, it could overdraw it and basically kill it or make it go into overcurrent or other kinds of issues, basically. Right? So 25 milliamp is peanuts, so we're going to keep our 4.7s. Okay, and we need to calculate our current limiting, because the IC can do, the load switch can do current limiting. they only go to the, if So we're going to use Claude again. Claude. We're going to make it read the table there. Okay. Wait, hold on. Okay, I open a new chat. Please look at this table and calculate 250 milliamps resistor value for me. Then please select a value with there. So I'm telling it to look at this table. I've just copy pasted it in there. And I want to limit at 250 milliamp, but the example table only tells us 600, 800, 1000, 1500, 2000. And I'm basically saying calculate 250 milliamp given those numbers, and then select a value resistor that's close to that, but very commonly available. I, of course, could do this myself, but now I get to drink again. Oh, it's actually searching for components using that MCP we installed in the previous stream. Okay, this one's done. Okay. It's a pure inverse. Okay, sure. The smallest deviation rounding. Okay. For 250 milliamp, we want 27.2 kilo ohms. But it's not an E24 or E96 value. Those are the most common. The two candidates are 27 or 27.4. Oh, and then it actually looked up stock on LCS. I didn't need to do that. Okay, so 0402 preferred. It has 81,000 in stock and it's ultra cheap. So we're just going to use a 27K 0402. Yeah, that's fine. Yeah, then it tries to lure me into asking more questions, but I'm not going to, because it'll burn my credits. Okay, so we need a 27K. Oh, wait, I have a resistor here. $27K, and I'm going to add a note, limits to 250 milliamps. Oh, okay, 251 milliamps. Ah. Why is the resistor thingy smaller than the explanation, but it's not with the capacitors? Wait, this is wrong. This is wrong, because this says 0805, but the footprint is 0603. I didn't change these, but where did I steal this from? So let's change this one. Wait. No. What? Okay. 0805. I stole them from here. Yeah, also wrong. Wrong. We would have found that out later when double checking that, but it's good to catch it now. Let's check these. 0603. Also wrong. Somewhere we forgot to change that and then I copy pasted it all over the place. This one? Good. This one? Good. 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 Oh, we didn't enter any footprints here. That's fine. Okay. Maybe here. Let's check. No, those don't have footprints here. Okay. Okay. So now we have we have relay 1, and we'll call this relay 1 5V. I don't know. I have to call it something, right? And then relay 1 5V, we're going to connect up to the relay here, because we have the plus and minus switch we labeled here, and then the load. And yeah, now it gets switched with 5 volt. This makes it a bit large. Let's see if we can move this down. That's good. Sure. It's odd. Don't need that. No, wait. What? Sure. Let's draw a box around that. No, they should be. If we worked on the labels, so if the label says 0805, we wanted an 0805. I just never changed the footprint, and now I've changed the footprints to match. But we haven't gone over footprint matching and stuff like that yet. So, yeah. Okay, so we now have our 3.3 volt GPIO to 5 volt, and let's copy that and make it 2. This one can go. Let's make this 2. And this needs to be 2. And then we have our solid state relay. Yeah, okay, I see it. Go away. Go away. There. So now we should have 5 volt control over the solid state relays that we are going to add on the board. And we now have 2 of those solid state relays that are being controlled by the output over here. Okay. What else do we need to do? I'm going to remove this. Don't really need it anymore. I think we should add some terminals for the buttons, right? Screw terminal. I'm going to use 01 times 04. What that means is 1 row with 4 pins. Okay. And I don't know. I'm going to put those over here for now. I'm going to make 2 of those. And the reason is we want to use no. Button 1. Wait, do we want a more elaborate? Yeah, we might want some. No, okay, so this I2C expander already debounces. No, we don't want any soldering. We want to try and prevent any kind of soldering if needed. If I ever have these made, it would also need to be for people who can't solder, right? Now I'm thinking about the buttons. I like having pulled high buttons, which you then pull low. We don't need to do any debouncing because the I/O expander already has some debouncing in there. No, but there's not going to be any physical buttons. It's more if like, the way I see it is you'll have one of these in a box on your wall. Then there's going to be a box beside that for the sensors. And maybe you want to add a box to the other side of that, or maybe on that side, I don't know, where you'll have some physical switches, which will be linked to this guy, which will be hardwired to your Home Assistant. So you could add some physical switches off of the baseboard we're building, basically. Yeah, so no soldering for that. But I'm thinking these ports by default are push-pull. No. No, the sensor board shouldn't have any buttons, in my opinion. The face will be used for sensors and not buttons, basically. Because that also has a metal back frame otherwise and things like that. So, no. So these will work differently, huh? So let me look up the documentation for this guy. Oh, great. There is an English version of this. Because by default, these are low. Okay. LED. Okay, we want GPIO mode. Yeah, we're pulling 80 and 81 low, and then I believe all the buttons are low to start with. Yeah, these are pulling high. Okay. Yeah, so 81 and 80 determine the initial state. And P0, okay, open drain, okay, or push pull, okay. So you can just get your favorite switching button panel, whatever you like. It can be the same buttons as you use for AC, except instead of wiring up AC, you wire up the wires that come from the baseboard, which is in the socket right next to it, and then you have your on-off button. Or even, you know, a press button or whatever. A momentary button, I wanted to say. Input capacitance. 0.1, typical 1, maximum 100. Okay. Yeah, that might not be enough, maybe. I knew it had something. High level output. Okay, it needs 1.4 in, that's fine. It can do our internal pull low. Oh, and we say, okay. No. Right, so if 81 and 0 ground, everything starts up low, which is okay. But then I need to have buttons that go from low to high. But especially because we also have those relays connected, we want those to always start in low, even though we have the resistor. So we can either start an open drain or push pull. Yeah, the 8 nanoseconds or whatever is that's not a lot. Let's see, we can go high Z, and then this is all 1. We don't want that. Oh, we have to be really careful if we configure this differently. So we can put it in high Z. That's, I believe that's open drain. And then these are 0. So we could put the relays on there or on here. Because then we have things that are 0 at boot, we have things that are 1 at boot, and we have things that are 0 at boot and high Z. I believe high Z is open drain, so it can be whatever, depending on the external resistor. Is high Z open drain? I guess so. What? The default GPIO after power on is high or high Z? Yeah, okay. Do they explain what high Z is somewhere? No. Yeah, okay, but high Z means state on open pin is not actively driving any voltage and presents high resistance, appearing open to the circuit. Okay, so we could use these high Z's or these 1s. But how does it work if you define it as an LED? We're not going to do that, but I don't want it to define it as an LED. I think there's no default definition for LED. That's always done in software after. You just have to make sure that it's not outputting a 1, because then it'll drive that LED. Or a 0. No, yeah. No, a 0, I guess. Yeah, okay, so this switches those, okay. So that's a configuration variable. Okay, after a default state, all GPUs are configured as output, which is the value to say, it's cleared and pulled in. Okay, we have that. Right, so we can just change the mode the port expander starts up in. Because I'd rather have pulled high ports that go low than the other way around. And we can either use these high Z's or we can use these ones, I think. But I wonder what the pull up strength is for those ones. I guess we can define it ourselves if we use those high Z's ones. Okay, let's do that. So we're going to switch from this mode, where everything is ground, or basically 0 when it starts up, to this mode, where we have to connect AD0 to VBAT. In our case, that's 3.3 volt. So instead of AD0 going to ground, like it was, we're going to connect it to, I'm going to snake it through here, to 3.3 volt. I don't believe I have to use resistors for that. Which will make it come up in a different mode. So, well, these relay pins, they have to be 0 at startup. Okay, so looking at that, we have P1 and P0. Okay, and we can use P1, 7, 6, 5, and 4, or we can use P0, 7, 6, 5, and 4. So let's do that. So that moves these to here. Because P0, 4, 5, 6, and 7. P0, 4... wait, no. Did it wrong? Yeah, no. P0, 4, 5, 6, and 7 are 0 at startup. No, did it wrong. Sorry. I needed the relays. There. Hey there, Akamos. And then we need pins that are high Z, I'm going to use. That is P0, 3, 2, 1, and 0. Okay. Oh, it makes it easy. There. And we're not going to use P1 for right now. We might use it for something later, but we still have 0 and 1 pins during boot available, so that's fine. Let me steal a circuit real quick. I'm going to disable the screen sharing real quick. One moment, please. Because I develop a lot of stuff, and we don't have to redevelop it. This is the pool high input / button circuit I generally use on my other boards, so also my production boards. It gets pooled high with a 3.3K resistor, but then it also has a 1K limiting resistor And, oh, this is a mess. Whatever. And it has a 0.1 microfarad capacitor on each of the button pins, basically. And we're going to have to rename these or move them. And that provides a little bit of debouncing and the automatic pull high and things like that. I don't like that. And that's worked really well in testing to not have false positives and things like that. Wait. Oh, was it cameras? Okay, so now... Oh, this is still the old stuff. Okay, hold on. Ah, funfair. Okay. So now we have our button 1, 2, 3, and 4. They go through this little circuit here, and then comes out button 1 high, button 2 high, button 3 high, button 4 high. This side is connected to the I/O expander, which is now in high Z mode. So it basically has an undefined state. We're going to pull it high during using our external circuit, and then we're going to pull it low when a button is pressed. And we're going to use two 4.4-pin terminals for that, which each have two buttons and two ground terminals on there. So that makes connecting a bit easier. That is interesting there, I test things. I suspect he might have been using some alcoholic beverages, which brings out the best in people. And then people who are susceptible to that, I'm going to say often drink too much, but yeah, and then use it as an excuse. I have some issues with drinking, not so much myself because I don't drink because I don't like the taste, but some other people drinking and then not being responsible for their own behavior and then doing it again the next night and because they're drinking again. But, maybe this is just a personal thing. Okay. Let's move this here. Let's give this a little name. Button terminals. And we'll move this to the right of the I/O expander. What? Why does this not line up? No! Why? Why does this keep happening? Can I delete this? Yes. Go away. Okay. Fixed it. I think. Did I fix it? Yes. Okay. So now we have some button terminals. We have our circuit and we have our terminals here. So we have defined our buttons. The relay already we worked on. This is so confusing that this is reversed. I could edit the footprint, but now I know it's like this. So, okay. I think we're actually getting close to being able to work on the PCB next. Right, this is VCC 5 volt because it's going here. Our PoE circuit. Yeah, because our baseboard basically needs to get Ethernet in. Oh, we don't have the Ethernet socket yet. Okay, we need to find an Ethernet socket. Let's kill a bunch of these. Doomboy, that is my exact point, but I try not to go into discussion with it because I don't know, doesn't always end well. Okay, we're gonna ask Claude. We're gonna ask Claude to find a part for us. How's that? We're gonna, because I want to drink, but a Coke, non-alcoholic. So, I want a RJ45 connector with integrated magnetics, magnetics, 100 Mbit full duplex, shielded. That's PoE capable, but I don't want a normal. I don't know how to call normally a connector. If this is the board, it sits like that. But we want a connector that sits like this, right? We also wanted to have the rectifiers inside of the port if possible. But let's see what it can find. I prefer LCSC. Now I get a drink while my cloth looks it up for me. Oh, Philip went to bed. Later, Philip. Good luck with your sister. Vertical RJ45, that's it. Well, it's hard work in this AI world. It's doing all the searches for us. No, it's not test things. I mean, you didn't really ask for that, so this guy should just go away. Hunting elusive vertical mag jacks. Uh-oh. It seems not able to find them. Oh, now it's going directly? Okay. What's it doing? Pinpointing vertical Honron. Okay. Oh, it's looking it up itself. Okay. Elusive vertical mag jacks is your favorite rock band. Yeah, mine too. What are we doing? We're designing a board that will bolt onto this existing product and add PoE sensors, relays, and all kinds of other crap that I want to have. So. It's doing a lot of work for us. Let's check out what it looked up here. Yeah, that's good. I test things. I mean, those people are unpredictable. Best to leave them to their own devices. This page isn't working. Okay. Oh, wow. Did my internet die? No, we have 0 dropped frames. My rebooting of the Switch worked. That's good. It's still... oh, it looked up more stuff. Oh, Link PP. Okay. Do they... Oh, they have vertical. Okay. We've integrated... Okay, they have them with integrated magnetics at least. But do they also have it with integrated magnetics PUE and the rectification? Without LED? Well, I guess we don't... I'd still like LEDs. We don't need LEDs, but... Holy, too many pages. Can we filter this? PUE. Oh, they have PUEs. Okay. Rectifying bridge, green. Oh, look at this. Whatever. Oh, they're really expensive. Let's see what it does. A vertical mag jack with rectifier. Bridge, green. Oh, green LEDs. No. We don't want green. Okay. Rectifier diodes. There. We want this one. So 1000 base T, RJ45 PUE vertical mag jack, riff rectifier bridge, green. No. What? I'm green. It's just wrong. Their description is wrong because the picture is right. 1155 BDNL, 1155 BDNL, and here. Yeah, okay, their description is wrong. Fine. Because the Gotta has those blinking lights. Yes. Okay. Oh, $4. What? Oh my god, these are expensive. Okay. Oh, is this top entry? No, is it? No. Oh, they sit flush on the board? Like this? The pins are on the bottom and then... Okay, that's okay. That's okay. Shield EMI tabs without. What do you mean? They're right there. This information is very screwed up. Green. I don't want green. Okay, that's good. I believe. Okay, we went on a tangent. Oh, wait. Is this board taking power from the cable or putting it in? Board is powered. Board injects power. Board is powered. We're going for AF. We're preferring 100 Mbit, but it's okay. Oh, okay. Wait. What did it all say? Short version, the full combination you want doesn't exist on LCSC. Vertical plus magjack exist. Rectifiers inside exist, but not both in one body. Every integrated rectifier magjack I can find is right angle because the diode sits... Okay. These are even more expensive. PUE taps. You want pink and purple. Do the LEDs call for extra pins? Actually, they do. Oh, that's a good question. Or a good remark. We don't have the LED pins. So on the LAN or the IP101, which is the IC they're using, that generates the LED signal. But those pins aren't broken out through the header to our baseboard, right? So the LED pins for the socket don't leave this board. So we can't make... Does their version have... No, their version, this is their version, it also doesn't have LEDs because their transfer connector between the boards doesn't have the pins. Okay, so we don't need LED pins or LEDs because, well, we can't control them. Okay, it might have found one. So let's look at this one. No, that's still not what we want. No. Yeah, okay, it's telling us we might need to do it in separate components. Okay, let me... this looked good, but we don't need the LEDs. So... PUE rectify... Okay, they only have versions with LEDs on there. I don't care. I actually don't need the LED indicator lights. So I believe the would be an... That's a link PP, right? Yeah. Yeah, I mean, in this case, we can't use the LEDs anyway, so, right, yeah. Let's see if it can find it on LCSC, and otherwise we'll have to buy it externally and then assemble it and blah, blah, blah. That's fine. I can check if... the Chinese version might have it. Oh, they do. Oh. I don't think they have any stock. Equivalent to 1 pallet? What? I don't want 1 pallet. Okay, but they have an LCSC number. So let's see if we can find it on the English LCSC. Oh, we can. Okay. It's just out of stock. Okay. Yeah, I mean, if the screen lights up, it's working. It's $3 a piece. Whoa. Okay, let me see on JLC. Oh, I need to sign in. Hold on. No, no, no. Okay. I was checking on LCSC if they have an easy order method. Seems that they do. So we could buy 10 on LCSC. No, I do have a password manager, but I have to enter a password for the password manager. So I mean, top camera keylogger. Yeah, exactly. Yeah, so we can use LCSC to pre-order these. And yeah. That will have everything integrated, which would be nice. So let's check that again. Do they have a data sheet? Oh, they have a drawing. Okay, oh, this is good. Okay, so they have the, okay, yeah, yeah. Okay, that's Bob Smith. Okay, and then they have the internal rectifier. And then we have the PW plus and PW minus, and that's exactly, if we do it simple mode, that's our VDD and VSS, right? So that's what we need for our PUE circuit. And then it's all integrated nicely into the socket instead of external discrete components. For now, I don't want to go external components. We could maybe look at it at some point, but especially because this is more of a for myself, but I'll maybe make some extra product. You know, I'd rather not spend the time of absolutely cost optimizing it by making it a lot harder and needing more prototypes and blah, blah, blah. So let's see what Claude has been able to find. That's a better catch than my table gave it credit for. And I need to correct myself. I had the not PUE. LCEC tables it as non-PUE. This is why you shouldn't trust AI. We were able to find it. AI said, nope, this doesn't do. And then we said, but wait, doesn't it do? And then it said, oh, hey, that is a great one. Oh, look, it's the unicorn it couldn't find. You're right, and I was wrong. And specifically wrong about the thing I told you didn't exist. Oh. This is the wonderful world of AI. Anyway, let's see what it says. 10145 MagJack with PUE, rectifier bridge, top entry, compliant. Which Halo cells? Yeah, okay, yeah. When I said rectifier, right angle, this part was sitting in my. Oh, okay, sure. Yeah, I don't know, Doom Boy. I don't know. It does have LEDs. I know it has LEDs. Oh, it has an easy EDA symbol. We might be able to steal that. It's a Halo's vertical. Okay. Temperature, that's all fine. The spec, why? Yeah, but we're not going to use anywhere near a lot of power. It's thinking Queen LED stuff. It doesn't need to do that. No datasheet and the symbols won't save you, else the datasheet field is null and the easy. Yeah, okay, well we can find that in the datasheet as we just did. So that's fine. Oh, okay. So it can't do mode B. Not too worried about that, actually. Okay. Yeah, okay, whatever. 70-degree rating should be fine, too. We're only going to draw like a few watts, like 2 or 3 watts, maybe. So that's all going to be fine. Does it have... Oh, it has a symbol. Oh. Oh, we can just import this. Let's go. Let's go. Import. Whoa, that was fast. Okay. Oh, it only has a footprint. Okay. No 3D models. Well, let's see what it has. Let's go. I wish normally I could press left and then it closed this whatever, but it doesn't do that anymore. Where is my Q import? There. No. Yes. Okay, so here's our Ethernet socket. Let's move this. Okay. Okay. Now we have a socket at least. I don't think it has an associated footprint, does it? Oh, it does. Wow, we can just use the same. Okay, that's good. Very good. Easy time. Yeah, with this connector, we're basically done. I think we're pretty much there. We then, next week, will have to match our symbols to a footprint. But that, that won't cost the whole time. And then we can start doing the physical layout stuff. Or the physical board stuff first and then the layout. So, let's make a start with this. I want to ground all the LED ports. There. Let me check in the data sheet. So pin 8 is not connected. This is the center tap. Okay. We have 9 and 10. What? This is wrong. This I thought that didn't make sense. So let me edit this. Hold on. Where does it say? Edit with symbol editor. And then we're going to edit the library version. And this isn't LED Y. I think this is. And then this isn't. So I believe this symbol is wrong. There. I think that's how it is. But we can check. We can check in the data sheet. So 13 is positive and 14 is ground for yellow. 13 is positive for yellow. 14 is ground for yellow. And 11 is positive for green. And 12 is negative for green. 11. Yeah. Okay. This is now correct. And we can put these names here now. So 9 is, oh, no. 9 is PW plus, 10 is PW minus, right? PW plus, PW minus. And then 6 should be connected to ground. Is that correct? Yeah, okay. 6 should be ground. And 7 and 8 is non-connected. Can we specify that? Unconnected. There. And 7 is RCT. We're just going to name them what they say in the datasheet. I'm not sure what RCT does, but that's fine. Rectifier, I guess. And then we have TD plus, TD minus, TCT, RD plus. So this footprint was wrong and incomplete. And RD minus. So that's transmit data, receive data, plus and minus, and TCT is, I believe, in the middle. I'm not sure what we're going to need to do with that, but we'll figure that out. Okay, let's save this to make sure we have that. Okay, let's save this. And now we go back to our schematic. Well, this is still wrong, but now we have to say right-click, update, update with library symbol, update. And now it's correct. Okay, so now it took in all the changes we made. Oh, 15 and 16 are shell, I think. I mean, they're probably these tabs. Yeah, they don't display them. Let's edit it some more. We'll call this shell. And we'll call this shell. Save. I'm actually going to move this up. Wait, stop it. There. Update. There. Okay. So now we have a nice symbol. I need to check what this one requires for the shell. We could just tie it to ground. That's the easiest solution. But generally, you want to tie it to ground with a capacitor and a very high resistance resistor. But I'll check that at some point. Okay. So we know VDD is our PW plus, and our VSS is our PW minus. So I'm just going to connect those with symbols. I don't want to route this all out in the schematic. It's not really needed in the schematic. Ground is pretty simple too. Okay, and then we're going to need these because those are coming from the screen board. So those are on that connector, and we're going to connect those over here. And we shouldn't reverse these because it's not serial. So ETH TX positive goes to TD plus, ETH TX negative goes to TD minus. Don't I need that in the schematic for it to be modeled in 3D design, or are those only needed there? How do you mean? No, we're making the connections, but we're doing it with symbols. And because this is the schematic, that's fine. In the end, on the board, we'll have to route it. But I mean, I could do this. Right? And then do this. So that's basically the same thing. But I mean, that just looks ugly and uncontained, and yeah, I don't know. This is basically the same thing. On the board, you'll have to actually route it, but we're not working on the board. This is a schematic, and we just need to see that it's connected. I'm gonna add a box here. This is all references. Yes, this is all references to everything. It's like the same that we're generating 5 volt here, but this same 5 volt symbol is connected here and here. That just means it's all connected together, but if you had to wire it all out in the schematic, it would become one giant mess. But that comes in the PCB stage. This is just defining the connections in a logical way, and then later we have to define them physically. But first we determine the logic, like how it's supposed to all be connected together, and then we get the mess how to actually do that physically. Yes, they're all the same 5 volt. Yeah, that's why I made a 3.3 volt and a 3.3 volt A. Those are now different. But anywhere where it says 5 volt, 5 volt, 5 volt, that's all connected together. And that's also why I have this 5 volt here, but also this one, because this is a custom label, because that goes back to the connector over here and over here. So right now you don't have to worry about all that. Everywhere where you need 5 volt, you just plump that 5 volt signal and done for the schematic. Yeah, I need to figure, I have to look up what I need to do with the shell and this RCT and TCT. Maybe we can ask AI. The socket has a RCT and TCT connection. I'm connecting it to a ESP32P4 with IP 101 Ethernet MAC. What do... AI, I'm getting a drink again. My background is IT. I was an IT consultant since my 17th year. So I'm now 47. I don't know, 25 years. But my IT consultancy was mostly for large storage and backup systems. That's why I still have a storage cluster and things like that at home. And I kind of started this about 10 years ago when I was building the current house, and I wanted to have all the LED lights individually controllable, and Philips Hue was already a thing 10 years ago. It was brand new, and stuff like KNX. But KNX I would have had to spend like 100,000 or 150,000 euros on stuff, which was insane. And Even for Philips Hue, I would have had to spend like 50,000, and it couldn't do what I wanted it to do, and low PWM frequencies and all kinds of other crap. And then I said, fine, I'll just design it myself. That's what this house is currently running on, what I designed 10 years ago. Because, I mean, that's running on a Quin LED Deca. So not an AN Penta Deca, but a custom, the DIY AN Deca, so the 10-channel one. There's one beneath here too for running these lights. And a lot of the house lights are still running on a Quin LED OG. But yeah, that's how I kind of got started with it. And it spiraled out of control into what it is now. With an internal bridge, TCT, RCT could mean either the phi side taps or the line side. Do not connect TCT or RCT to any supply. For the center tap of the transformer, do not connect to any power. Sure. You're running Tuya. Oh no. Yeah. I don't like that. What did it? Sorry, just reading here. No, those are specifically different. La 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 la. Okay, we have an isolated design. Yeah, with addressable LED, things can get out of control really quick, and provides China workers control monitoring. You mean the Tuya? Yeah. I don't like non-local stuff. I actually installed new smoke detectors today, and one of the reasons I chose this brand, the Xsense Pro, is because their base station has an MQTT Home Assistant option in there for local readout and control. Now, I don't know if I'll ever connect it, but it did sway me to purchase this brand versus another, which didn't have that. So, Yeah, I replaced 4 smoke detectors today. Because I had a Nest Protect, and those were awesome. I really liked those. But they stopped making them. And they're now 10 years old. And yeah. Oh, you have one that has Zigbee. Yeah, I don't have Zigbee, so, Both return to secondary ground. The same. Okay. I don't want to know all this. I just want to know where to connect this. Don't mention my own boards. What do you mean? Yeah, no, I talk to it about dig quads and stuff like that sometimes, so... yeah. I just want to know what I need to connect here. Jesus. Hmm. Let's see what it comes back with. Yeah, exactly, Heckamos. Often it's good, but in this case, it's totally unrelated, so... Let's see if there's been any... let's see, RCT pins Ethernet socket. Ah, I think I know what I need to do there. Right, I need to look up a different design I've done. And my answer will probably be in there. One moment. Okay. In that design, I used a 100 nanofarad to ground for each of them. And that worked. So, let's see what Claude says, but... only power input. I don't know, Hackamos. You built it. What? It wants to search reference board. Okay. Sure. Oh, it's downloading some expressive here. Yeah, that's good. Let's also look at that. So, okay, but are they doing anything PoE? They don't. Where's their Ethernet? Okay, they have TXCM and RxCM. And those are coupled to ground. Oh, to PoE board. Okay, yeah. Yeah, sure. Alright, with 10 NF, 100 volts. Alright. Let's see if Claude comes back with that too. Yes, 1 capacitor per center tap to ground, no supply. The datasheet, built in. Yeah, I know. 2 separate caps. Okay, 10 NF. Note the voltage rating, 100 volts. Sure, that makes sense given the PoE. Everything else, 1 caveat. The PDF sheet. Yeah. Okay. Yeah, we can do 100 volts, that's fine. What kind of size do they use here? Did they say? Oh, they actually have a cap and then a resistor. Ooh. Okay, on your board, the only thing you want, and that's okay. Yeah, we don't have those because those are internal, or I don't know what they mean here, but that's whatever. Okay, so we want 2 capacitors, 100 volts, and we'll adjust these to 10 NF, 100 volts, and we want another one, and we'll abuse this ground. What? There. Oh, sorry about that. Yeah. So basically, the Claude, he said we need to use 10 NFs because that's used in this reference sheet. That's correct. But their sheet, or they don't, or they have built-in 49 ohm. I don't know. It said not to use these resistors. So we're not using those. Basically, we just need 10 NF 100 volts to ground. But I'll look that up off stream if that's correct. I think so. So we connected that, and I also need to look up a shell. So I'm going to say shell. And center taps. Those are some questions I need to research. And yeah. Then next week we can start linking all these components to footprints. We're basically going to hit this button here. Click. And you see these all don't have footprints. We're going to need to give those footprints. And once those have footprints, we can go to the PCB. Then we have to design the physical size and dimensions of the PCB and where that connector is. And then we can start routing. And once that's done, probably the stream after that, we could maybe order a prototype. Whoa! And then at some point we'll build a prototype. And then we'll have our first step completed, and then we can start designing the sensor board and stuff like that, right? We're just designing in theory now that this has all the connections our sensor board needs, But we'll probably discover when we start designing the sensor board we need a pin more or less or whatever. But, we have I2C, we have LED data, and we have 4 leftover pins we can use. We have 5 volt and 3.3 volt with its own regulator. Should be okay, but maybe we'll discover, oh, we need another pin. But we have some pins left over, so I don't know. We'll see. I don't know. Yeah. Okay. Yeah. Let's close this. Close this. Close this. I don't really have a secret for this week. I had no time to prepare anything because I worked on the 24 volt issue 24 hours a day. Any questions? I don't know. Sure, no problem, Foxionaire. In theory, we stole all the footprints from LCSC, but we'll find out next week, and maybe we have to draw one. We don't know yet. Well, you can. Yeah. If it were a 5 volt issue, would you only work 5 hours a day? That's a good one, Omakovala. Probably not. I'd still work 24 hours a day, but you know how it goes. Yeah, it really sucks. But I think we have mostly under control now. As I said in the beginning of the stream, we have mitigation and revival methods for everything. I'm working on bringing out the kits and things like that. I hope to have those end of next week or something like that. And then we should have it mostly under control, I think. But we'll see how many boards come in. Hey, Jamie. You're busy DJing. Well, it's in your name, so I mean... Any other questions? Otherwise, I'm gonna call it quits. It's warm here. How warm did it become? 26.5 degrees. Ugh. So because of all the lights and the computer and all the cameras and power supplies and all the I don't know what, it really warms up in here. I think we started at 24 degrees. Do you play Dead by Daylight? I do not. I used to play some League of Legends Teamfight. Don't do that very often anymore. But I do play some Battlefield 6. I like playing some matches now and then. And there is a new game I've been playing, Tech something. It's about a little car and you get upgrades. And it's like a rogue shooter. But then, with a little tech car, you can upgrade with various guns and upgrades and things like that. So, yeah. Your quads have been fine on 24 volt. Yeah, most of them have been, but they might end up dying sooner than than we'd like. But it's very hard to say if and when that will happen. So if you want to be sure, I'd recommend getting the mitigation option. So when the buck converter kits are available, getting one of those kits, and then you're sure it'll keep running. And otherwise, you're good for 1.5 years because I'll send you either a kit or a replacement, preferably a kit. And then after that, yeah. Okay, well, it hit 12 o'clock. So I'm going to call it quits. Thank you all for watching another WPS stream, the wall panel sensor stream. We're getting closer to developing a PCB, and then at some point we're actually going to make it. And, that's going to be exciting. Thank you for watching, and I hope to see you back in a video, or maybe the next live stream, or on the Discord server. Bye-bye, guys.